So we started from linear operators, right? And we gave the definition. So L is a linear operator. If we can do this, okay, so now we go to our example 2. So is L defined by this linear? So remember we said if L, so it's that if LU is linear, then L alpha U plus beta V is equals to alpha LU plus B LV. So this is more like you're making a contradiction. Okay, so you're making a contradiction. Is LU equal to this linear? You start with a statement. If LU is linear, then we're going to have this situation, right? Yeah. So now we can put where there is L, where there is U, we're going to replace with this. Okay. Additionally, we can say alpha, beta are real numbers. Okay, we can say that. So now we'll do this. So L, where there is U, we replace with alpha U plus beta V. This will be equal to, okay, let's use this form of the differential equation. So where there is U, we replace with alpha U plus beta V with respect to t plus, so here there is a U here, so it will be alpha U plus beta V. Then again we have times alpha U plus beta V with respect to x. Okay, so we see that we can distribute the t inside, right? So it will be alpha ut plus beta vt. And why we're distributing the t inside, it's because we don't have any products. Okay, so it's more like alpha is a constant, so it's just the derivative of u. Same applies to v here. Then plus, so here we leave it as it is, alpha u plus beta v. Then here we can distribute, so times alpha u plus, okay, alpha ux plus beta vx. So here we would have to multiply, and we'll group the u's alone, and we'll group the v's alone. Okay. So expanding this, it will be this times that, so we see we're going to have alpha u ux squared. Okay, alpha times alpha, I mean, no, it's alpha squared, right? Alpha times alpha, alpha squared. Then we're going to have ux. Okay, then alpha times beta will be plus alpha beta, then u times v, it will be u vx. Okay, we come to beta. Beta times alpha, it will be plus alpha beta v ux. Okay, then beta times beta, it will be plus beta squared v vx. We start grouping those that have u alone. So we see that this has u alone, this has u alone, and that's all. This has u and v, so we can't group it. Remember, we should write it in the form L of u plus of v with some constants here. Okay, so we get those that have u, so we have alpha ut plus alpha squared u ux. Then those that have v alone, okay, so that is plus beta vt plus beta squared v x. Then there are these terms. We have plus alpha beta u vx plus alpha beta v ux. So as you can see already here, we cannot separate u and v alone. So that is a problem that we have. Then the second problem that we have is here. When we factor out alpha, we're going to have ut plus, we're going to have one alpha term, alpha u ux. Same applies here. When we factor out beta, we're going to have v plus beta v vx. You see, we have beta here and alpha here, but originally our equation lu is equal to ut plus u ux. There is no any term here. Okay, so we can conclude to say that this is not equal to alpha lu plus beta lv. Therefore it is not linear. It is not a linear operator. Okay, and that would be our conclusion. So let's see what you got yourself.